If you're a web developer, you've probably used REST APIs. They are everywhere, but there are several other types of API being actively used across software development today. And in this video, we're going to go through every single one of those APIs. But first, what even is an API? It stands for Application Programming Interface, which is a terrible name because it kind of tells you nothing about it. So forget the acronym. The real way to think about it is that an API is a contract. Two systems agreeing on how they will talk to each other. So system A says, if you send me a request that looks like this, I promise to send back a response that looks like that. That is it. People use the analogy of a restaurant, and I really also love that as well. Today, we are focusing on the architectural styles of API, how they are built, and how they communicate, all these different kinds of APIs. There's a separate conversation about the access types because we have public APIs and private APIs, but that's for another video. We'll use the same example throughout. We have an imaginary bookstore API that has books, and there's authors, there's reviews and others, so that we can see how each of these API types tackle the same problem differently. REST APIs. This is the most common one and the one that you would probably be introduced to first if you start learning coding today. REST stands for Representational State Transfer. So REST actually is a style where you treat everything as a resource and use the standard HTTP methods to do things to those resources. So in our bookstore, we would have these endpoints. So REST is pretty straightforward. You see the pattern, the nouns is in the URL, the verbs in the HTTP method, right? Very clean. So if we have a request that looks like this, to get book 42, the response will look like this. There are three things that make REST what it is. Number one, it is stateless. Every request contains all the information that the server needs. The server remembers nothing between requests. This is what helps REST scale horizontally. Any server can handle any request because none of them hold section states. Number two, it is platform independent. Your iPhone, your Android app, your web app, even your smart fridge can all talk to the same REST API. Number three, it uses standard HTTP status code. 200 OK, 201, 400, 401 unauthorized, 404 not found. These are universal. So what companies use REST? Literally everyone at this point. I feel like REST is the default, kind of. But REST has a downside, overfetching and underfetching. Those are like two downsides that REST API have. Say you want a book title and its author's name. You hit the get request, say get book 42, and that gives you the whole book object, including the stuff you don't need. I just need the book title. And then you have to make another call to author 7 just to get the name. 2 trips, a lot of wasted data. Imagine if you want to do this for 100 books. That's about 101 requests, right? There is a name for this problem. Actually, it's called the N+1 problem. But back to the overfetching and underfetching issue, it is the downside of using REST API. And this pain point is exactly what GraphQL was built to solve. And that leads us to the second type of API, GraphQL API. GraphQL was built by Facebook in 2012 and was open source in 2015. They had the exact problem at scale. Their mobile app was making multiple requests to render one screen. So the big idea is that instead of a bunch of endpoints, you have just one endpoint, and the client sends a query describing the exact data it wants. So the server returns exactly that, no more, no less. So instead of 2 REST API calls that we did earlier, we just have one GraphQL API, one GraphQL query rather. Now GraphQL has 3 operations type: queries for reading data, mutations for writing data, and subscriptions for real-time updates, which piggybacks on WebSockets. We'll get there. But GraphQL also has limitations. Caching is hard. With REST, you get free HTTP caching by URL. With GraphQL, fortunately and unfortunately, every query goes to the same GraphQL URL. So you can't cache by URL. You need some application level caching. And also that N+1 problem we talked about earlier is actually worse in GraphQL because each field can independently fetch data. A query for 100 books with their authors can fire 101 database calls if you are not careful. Next up is SOAP. According to the internet and Reddit, because I believe everything I read on Reddit, SOAP is the grandfather of API styles. It uses XML for everything, strict schemas, incredibly verbose. Every message comes wrapped in an XML envelope with a header for metadata and a body for the actual request. And the contract for every operation is defined in a WSDL file. SOAP has strict types. Every operation is enumerated. Every field is typed. Now, this is another cool thing about it. It is protocol independent. REST is almost always used over HTTP. SOAP can run over HTTP, SMTP, TCP, and that flexibility is why enterprise systems love it. SOAP also has built-in standards that REST doesn't. WS security, WS atomic transaction, reliable messaging, and this is why banks use SOAP. When money moves between two banks, this is money we are talking about. You cannot have a we kind of think it happens situation. You need a contract that says this happened exactly once or not at all with cryptographic proof, and SOAP delivers on that. You probably won't build a SOAP API in 2026, but you might have to consume one if you're integrating with a legacy system. I know that governmental systems too can use SOAP. I think so. Next up, gRPC. When you hear gRPC, think speed. gRPC is made by Google, and the G in the acronym officially changes meaning for every release, which is like the most Google thing ever. Sometimes it's good and it's green and it's whatever. It's kind of a running joke. The RPC part stands for Remote Procedure Call. Let's forget gRPC for a second. What is RPC? So the idea behind RPC is simple. It's not simple. But you want to call a function, but the function lives on another computer. Instead of thinking, oh, I need to send an HTTP request and pass JSON, you just write it like you are calling a function. You just write getBook42, like a random JavaScript function. And the framework handles the network stuff invisibly. It would look like a normal function, but it's actually eating another server. That's RPC. RPC is kind of functions and argument. That's like the model. Now, gRPC is not the first RPC. There are older versions. We had XML RPC and JSON RPC. They worked, but they were slow because they sent function calls as test. And test is bulky and expensive to pass. Now, gRPC came to the scene and modernized RPC with three things. Number one, it uses protocol buffers instead of JSON. And protocol buffers is a binary format. You define your data shape in a .proto file. Now, a JSON object that is about 200 bytes might be just 60 bytes in protobuf. So imagine that difference across millions of requests. That is massive bandwidth saving. Number two, it uses HTTP 2. Now, HTTP 1.1 is what most REST API uses. You send one request per connection at a single time. HTTP 2 lets you multiplex. That is, you can send multiple requests, share one single connection simultaneously. Number three, it supports 4 communication patterns: the regular request response, server streaming, client streaming, and bidirectional streaming, all over a single connection. You can't easily do that with REST API. So, because of all of this, gRPC is significantly faster than REST. And that is why it is used by big companies like Netflix, like Uber, like Spotify, and high-frequency trading platforms. But gRPC struggles with browsers. They cannot speak it natively. Browsers cannot. So it is mostly a backend to backend tool. Next up is WebSockets. This is the problem that WebSocket comes on the scene to solve. Regular HTTP is request response. The client has to always speak first. Now, if the server now has new information, a new chat, a new notification, it has no way to speak to the client first. The client has to keep asking. And this concept is called polling. And it is wasteful. Think about it like this. Imagine you have a mailbox outside your house and you have to constantly walk outside to check. You walk outside, you check, nothing. You walk back. You walk back outside, you check, nothing. You walk back over and over again. Waste of resources, right? WebSockets fix this. A WebSocket is a long-lived two-way connection. The client can send to the server can send to the client anytime in real time. How does it work? It starts with a normal agreement, handshake, just like every other. The server sends a special HTTP request with an upgrade header that says, let us switch to WebSocket. And the server agrees. They shake their hand, they agree. And from that point on, the connection is no longer HTTP. It is a different protocol that is optimized for two-way messaging. The channel stays open as long as both sides want it. Real-world usage is Figma, collaborative editing. You see someone consult the CEOs, WebSocket. Multiplayer games, WebSockets is very useful for these scenarios. Next up, we have Webhooks. Webhooks aren't really an API type. They are a pattern, but they are so important you will bump into them constantly. So the mental model of Webhooks, simple. It is a reverse API. In a normal API, your code calls someone else's server. In a webhook, someone else's server calls your code. Instead of the polling issue that we talked about earlier, did it happen yet? Did it happen yet? Going back to check, you give your service a URL once, and they eat it whenever something happens. So instead of going out to check your mailbox every 5 minutes, you have a mailman to ring your bell when something arrives. If you set up Paystack, you probably know about Webhooks. Let's say we're using Stripe to take payments on the bookstore. So on Stripe's end, you will say, when the payment succeeds, post to this URL. So if a customer pays $18.99, Stripe will post the event to your URL, and your server can mark the order as paid or send a confirmation email or whatever and respond with 200 OK. There are 3 things that you need to know about webbook in production. First is signature verification, because think about it, anyone can post to your URL claiming to be Stripe. So real webbook providers sign their requests so that you can always verify. Number 2 is idempotency. Webhooks can be delivered more than once. So if you fulfill the order every time the webhook arrives, you might fulfill it twice. So you store the event ID to ignore duplicates. And number 3 is retry. If you respond with non-200 or timeout, the provider retries so you don't lose events when your server is briefly down. You see webhooks everywhere. Stripe for payments, Paystack for payments, GitHub for code pushes. This is actually what triggers CI/CD. Last but not the least, WebRTC. WebRTC was designed to let 2 browsers or mobile apps talk directly to each other with no server processing the actual media in between. It can happen in a simple one-to-one call. Your video goes straight from your device to the other person's device. But at scale, it gets complicated. Now, if you think about Zoom, Google Meet, Discord, they kind of use some extras called selective forwarding units for group calls. So your video goes to SFU, and SFU forwards it to everyone else. Basically, the server is not decoding or recoding your video. It is just routing it, and it's pretty efficient. But the whole logic behind this is crazy, because your laptop or your device doesn't have a public IP address. It's behind your router, behind your ISP or whatever. And the same is for this other person. So how do 2 devices that don't have public addresses find each other? WebRTC handles this with a protocol called ICE, and it uses ton servers, and it is a whole lot. WebRTC can be seen in Google Meet, Zoom's web clients, Discord, Microsoft Teams, peer-to-peer file transfer apps. So which API is the best? There is no best. The best API is whichever fits the problem. If you picture a modern app, right, most of them actually have layers of this different kind of API, right? Use REST for the standard crude API that front end talks to, and GraphQL for complex data needs across many entities. gRPC, you use it between internal microservices. WebSockets for real-time chat and collaboration. Webhooks for receiving events from third-party. WebRTC for video, voice, peer-to-peer. You use SOAP if there is a legacy enterprise system in the basement. Each tool fixes its own problem. There is no single best. There's just best for the job. I hope you enjoyed this video, and see you in my next one. Bye.